Hey Accelerated Algebra, you're welcome to fast forward or kind of jump through this video and pause it and whatever you need to do to make corrections to this last part of problem set 11 before you turn it in. So based on what we did in class today, you might find it better to rewrite this equation in the way that I have done it here. And then we know from what we did with Desmos that this makes it go up 5, and this part is going to make it go right 3, and this part is going to make it reflect. And all of that helps us know that the old vertex used to be at 0, 0, but now it's going to go right 3 and up 5. So our vertex is going to be here at 3, 5. Then for the intercepts, you plug in 0, of course. For the y-intercept, that's easier. You just have to plug in 0 for x. The x-intercept, I recommend that when you're solving this, you isolate that absolute value sign. So I'm going to plug in 0 for y. So that I can see that I've got x minus 3 in absolute value bars equals 5. But of course that means either x minus 3 equals 5 or x minus 3 equals negative 5. So then I've got x equals 8 and x equals negative 2. So my two intercepts are going to be 8, 0 and negative 2, 0. So here's 8, 0, and then we've got negative 2, 0. And of course my y-intercept was 0, 2. So we can see that this just ended up being this upside down and translated absolute value graph. Okay, on this one, you're really just doing the distributive property. Just make sure that you're really careful as you're doing it with the x squareds and with the negative signs. So just check and make sure that you've got all your signs right. You combine like terms and all that good stuff. You'll notice that the next problem, it's the same thing, right? It's just that instead of doing times x and times 2 separately, now we're just doing times x and times 2 sort of all together with that binomial. Okay, great. And I've kind of color-coded as it works, and you can see that all of these answers are exactly the same as these answers. This problem, a lot of students did sort of by example, by choosing a length and a width, and I thought that was a great strategy. So if we start with a rectangle that's 20 by 30, then if we increase both dimensions by 10%, of course 10% of 20 is 2, so then we've got 22 and 33. So let's just look at the area and the perimeter of both of these. Here, this is easy to see. The perimeter is a 10% increase. But from here to here, that's a little harder to see. So I'm going to do a calculation. Well, the increase was 126. And I'm going to compare that to the original being 600. If I go ahead and divide those, I get 0.21. So this is a 21% increase in the area. So for this one, it tells us that the velocity is going to be 0 at the max height. So we're just going to put 0 for the v, or the velocity, and solve from there. And we get 1.375 seconds. If you wrote that as 1 3/8, that's also good. For these two graphs, y equals x minus 3 has a y-intercept of negative 3, and then a slope of 1. So it's going to look like a line mostly like this, right? And then our absolute value of y equals x minus 3, y of absolute value x minus 3, that moves to the right 3. And so the graphs kind of match up for one part. For this part, the graphs match, right? Okay, this one can be done a few different ways, but I'm going to share a solution that a student did that I thought was pretty good. So first we're going to change the miles per hour into miles per minute. So we've got the walk part and the run part. So the walk is at 4 miles per hour, so that's 4 divided by 60 miles per minute. And then the run is 8 miles per hour, so that's 8 over 60 miles. So let's let W be number of minutes walking. Then we know that 11 minus W can be the number of minutes running, because we've got 11 minutes altogether. So remember that we've got rate times time equals distance. That's what we're going to do here. We're going to set our distance equal to 1, because we have to go 1 mile. All right, so the distance that we went walking is 4 over 60. That was our rate in miles per minute, times W minutes. And then running, we did 8 over 60 times 11 minus w. Now, when you go ahead and simplify all that, you're going to have 4w minus 88 minus 8w over 60 equals 1. So 7 minutes of walking. She's doing a classic mistake of taking the positive of each part, but we really have to consider them separately. So if this is an absolute value equals 5, that means we have two equations to solve. And so x plus 6 equals 5 doesn't work with either of those. So I would say don't agree, and maybe you can explain that in words exactly why that doesn't work to take absolute value of each part. Okay, so if we want to do the distance to the y-axis, and this was one that I saw some mistakes on for sure. We want to make sure, like, think about where 11,7 is. So let's just draw a little graph here. How far are we actually from the y-axis over here? Well, over here on the y-axis, equal to our height is 0, 7. So how far away are we? We're actually 11 spaces away from the y-axis. And then -5, that's going to be on the other side, right? We're going to compare this to, say, 0, 9. That's going to be 5 spaces away. This one is, of course, going to be 4 spaces away. And this one is going to be x spaces away. So it's easy to think that you want to look at the y-coordinate to know how far you are from the y-axis. But really, the points that are on the y-axis are always 0 something. So when we've got, for instance, 4y, how far away is that from 0y? Well, it's 4 spaces away. And then for the next one, you can just use point slope form, which I saw a lot of people do. Right? Just make sure you've got a plus 4 there. 1/2 x minus 5. This is a lot like the one that we looked at the very beginning of class. So there are going to be, I'm going to show two ways of doing this one. We know that 5% acid. So in the end, we want to have the amount of acid over the total is equal to 5 over 100. So how much acid do we have? Well, there's none being added from the water, just the original amount. So 12% of 100 is the total amount of acid. And then how many liters do we have? Well, we started with 100 liters, and then we added X liters of water. So you could set it up that way and solve. The other way to think about it is in sort of a more linear equation way. So how much acid do we start with? Well, we start with 12% of our 100 liters plus 0% of our X liters. And then how much do we end up with? Well, we end up with 5% of our total number of liters, which is 100 plus X. 140 liters of water. Awesome. So make sure that you submit your work with the corrections on Schoology, and I'll see you in person on Friday.